When I was a child, our solar system had 9 planets. Yes, back then Pluto was considered the smallest, youngest, and most distant member of our planetary family. But in 2006, everything changed. On August 24, 2006, the International Astronomical Union officially downgraded Pluto's status to a dwarf planet. At the time, the decision caused massive debate. People were angry, they protested, and many disagreed with the ruling. But in the end, Pluto was no longer considered the 9th planet. People complained about the decision, but scientists were not entirely wrong. Because for many years, Pluto had failed to match the characteristics expected of the mysterious Planet X. Its mass, size, and orbit did not fit the profile of the long-hypothesized 9th planet. However, that does not necessarily mean there is no 9th planet at all. For decades, scientists have continued searching beyond Neptune for a mysterious hidden world. But why? Why can't Pluto be Planet 9? To answer that question, we need to go back in time. Humanity had known about 5 planets for thousands of years: Mercury, Venus, Mars, Jupiter, and Saturn. Until only a few centuries ago, we didn't know the others existed. For example, Uranus was discovered completely by accident in 1781 by astronomer William Herschel. The discovery created enormous excitement. Soon afterward, mathematicians began studying Uranus and noticed something strange about its orbit. There appeared to be another unseen object affecting both Uranus and its moons. A mysterious, undiscovered object was influencing the distant planet. From that moment on, scientists began searching for this hidden body. Astronomers and mathematicians tried to determine what it was and where it might be located. Then, in the 1840s, 2 mathematicians independently calculated its position: French mathematician Urbain Le Verrier and British mathematician John Couch Adams. Le Verrier claimed that there had to be another planet beyond Uranus, similar in nature to it. He even mathematically predicted its location, but he needed observational proof. So in 1846, he sent his calculations to the Berlin Observatory. Using Le Verrier's data, astronomer Johann Galle began scanning the night sky. And on September 23, 1846, Galle successfully discovered Neptune using Le Verrier's calculations, with only a 1-degree margin of error. Yes, Neptune became the first planet discovered through mathematics before direct observation. At first, Neptune seemed to explain the orbital anomalies beyond Uranus. But as astronomers continued observing the outer solar system, they realized the anomalies did not fully disappear. According to calculations, there still appeared to be another massive object beyond Neptune. That is why scientists began searching for the mysterious Planet X. However, the technology of that era was extremely limited. Discovering such a distant object was nearly impossible. Then, on February 18, 1930, American astronomer Clyde Tombaugh discovered Pluto at the Lowell Observatory in Arizona. At the time, many believed the mystery had finally been solved. Planet X had been found. But over time, problems began appearing again. Pluto existed, yes, but it did not truly fit the profile of the missing planet scientists had been searching for. The biggest issue was its mass. Pluto was simply too small. It lacked the gravitational influence needed to significantly affect giant planets like Uranus or Neptune. Its orbit was also unusual compared to the other planets. Still, there was little scientists could do at the time. Technology was not advanced enough to search farther into deep space. So Pluto remained the official 9th planet throughout most of the 20th century. Everything changed in the 1990s when modern telescopes became powerful enough to study Pluto's region in greater detail. Scientists began discovering many other objects beyond Neptune: dwarf planets, asteroids, and icy bodies. By the early 2000s, astronomers were certain Pluto was not alone. It was part of the Kuiper Belt, a vast region filled with objects similar to Pluto. Dwarf planets such as Eris and Sedna were discovered, and many of their properties resembled Pluto's. In fact, Pluto behaved more like the objects in the Kuiper Belt than like the 8 major planets. At that point, the scientific community faced a difficult choice. Either Pluto would remain a planet, which would mean Eris, Sedna, and countless others might also need planetary status, or Pluto's classification would change. If astronomers had chosen the first option, our solar system might have ended up with hundreds of planets. So, in 2006, the International Astronomical Union made its final decision. Pluto was reclassified as a dwarf planet. But that decision created a new mystery. If Pluto is not Planet 9, then where is Planet 9? Whenever this topic comes up, people often ask a fair question. If Planet 9 exists, why haven't we seen it yet? We can detect planets hundreds or even thousands of light years away. How can we fail to detect a planet inside our own solar system? At first glance, that sounds logical, but the answer is surprisingly complicated. Ironically, discovering exoplanets hundreds of light years away is often easier than discovering a distant planet in our own solar system. Most exoplanets we detect orbit extremely close to their stars. Because of that, they noticeably affect the star's light and motion, making them easier to detect. Some orbit their stars so closely that a full year there lasts only a few hours or days. But detecting a distant object in the outer solar system is much harder. The Kuiper Belt region is incredibly dark, cold, and far away from the sun. When an exoplanet passes in front of its star, we can observe changes in the star's brightness. But a dark planet drifting far from the sun produces almost no detectable signal. To understand this better, consider Pluto. The amount of sunlight reaching Pluto is roughly 1,000th of the sunlight reaching Earth. Pluto's surface is never brighter than twilight on Earth. Detecting reflected light from such a dark and distant object is extremely difficult. But then another question appears. If we can detect hundreds of dwarf planets and asteroids in that region, why can't we detect a massive planet? According to many calculations, Planet 9 should have at least 4 times Earth's mass. Some scientists even believe it may be a gas giant. So why can't we find it? There are 3 main explanations. The first and least accepted possibility is that Planet 9 simply does not exist. According to this hypothesis, the combined gravitational influence of multiple Kuiper Belt objects creates the illusion of a single large planet. But most astronomers reject this explanation because the total mass of known Kuiper Belt objects is far too small to significantly affect Uranus or Neptune. The second possibility is far stranger. Planet 9 might not be a planet at all, but a black hole. At first, this sounds absurd. Normally, a black hole would have far more mass than the Sun, meaning the Sun should orbit it, not the other way around. But some scientists have proposed the existence of primordial black holes. According to one hypothesis, tiny black holes may have formed shortly after the Big Bang due to extreme density fluctuations in the early universe. Most would have evaporated almost instantly, but some may have survived for billions of years. A primordial black hole could theoretically have a mass only a few times greater than Earth's. One idea suggests that such a tiny ancient black hole may have become trapped by the Sun's gravity and now quietly orbits in the distant outer solar system. We may not detect it because, despite its mass, its physical size would be incredibly tiny, perhaps only a few kilometers wide. Since it would consume very little matter, it might not create the glowing accretion disk that normally reveals black holes to astronomers. Still, there is a major problem with this theory. We currently have no direct evidence that primordial black holes actually exist. The third and most accepted explanation is that Planet 9 really is a frozen gas giant. Beyond Mars, all major planets are gas or ice giants: Jupiter, Saturn, Uranus, and Neptune. According to current models, Planet 9 may be somewhere between Earth and Uranus in size, with a mass 4 to 10 times greater than Earth's. But because it would orbit extremely far from the sun, temperatures there could drop below -220 degrees C. Under such extreme cold, many gases in its atmosphere may have frozen into solid crystals and collapsed onto its core. In other words, this massive world may not resemble a giant, colorful planet at all. Instead, it could look like a dark, frozen object only a few hundred kilometers across, blending in with the countless icy bodies of the Kuiper Belt. Of course, there are many wild theories too: alien bases, hidden portals, and other science fiction ideas. But I prefer focusing on the scientific possibilities. In summary, Pluto lost its planetary status for several valid reasons. But many astronomers and mathematicians still believe that a true ninth planet exists somewhere beyond Neptune. Finding it, however, is incredibly difficult because that region of space is distant, cold, and almost completely dark. Still, science now has powerful tools. We have the Hubble Space Telescope. We have the James Webb Space Telescope. One day, a determined mathematician or a lucky astronomer may finally uncover the truth about Planet 9, or perhaps even discover an ancient primordial black hole. Personally, I truly hope I live to see the day this mystery is solved. So what do you think? Do you believe there is a hidden ninth planet waiting to be discovered? And will humanity finally uncover it within our lifetime?
Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.